I'm Pushpita Chanda. I'm a PhD student at IIT Delhi and under nuclear program. So today I am the TA for Newtonian Mechanics with examples. This is the week 8. Let's begin the tutorial. So first I want to discuss inertia tensor. So why do we need inertia tensor when we have moment of inertia? Inertia is only useful when rotation happens about a fixed axis. But if rotation is taking place about a fixed point, then the moment of inertia and all the other rules for rotational motion is not valid. We need then inertia tensor. So when rotation a fixed axis, we have L is equal to K is equal to half of I omega square. But when rotation is about a fixed point, shear tensor and the equation, let's say it's 1 and it's 2. Equation 1 and 2 became here x, y, z is Lx, Ly, z is the component of angular momentum. This is shear tensor. Equation 1 equals this is inertia tensor will not like this, and equation 2 becomes like this. K is equal to half of omega x, omega y, omega z, I x x, I x y, I x z, I y x, I y y, I y z, I z x, I z y, I z z. Okay, so we can write it half of omega moment of inertia x, this omega. So why do we write this omega x, omega y, omega z are components of angular velocity in horizontally and this is vertically? Because due to matrix rule, we know this is 3 by 3 matrix form, and so this is the row number and this is the column number. Due to matrix multiplication, like for successful matrix multiplication, it should have row number 3 and this matrix should have column number 3. So that's why we have 3 columns in one row and here 3 rows, one column. Now, in moment of in inertia tensor, there are 9 elements. First, we will discuss the diagonal elements. They are called principal or moment of, no, they are called moment of inertia. Principal moment of inertia is another thing. So they are called moment of inertia. So they are Ixx, Iyy, Izz. For discrete case, discrete mass distribution, this is mi yi square plus zi square. Here it becomes integration of y square plus z square. This is mi xi square plus zi square. Here it is y x square plus z square. And for izz, this is xi square plus yi square, and this is square plus y square dm. These are called moment of inertia. And non-diagonal elements are called products of inertia. This became mixiyyi, and this is xydm. This is mixizzi. This is xz dm. This is y, and this is zy. So the elements of moment of inertia is the elements of inertia tensor. Out of 9, there are 3 moment of inertia and 6 product of inertia. Out of the 6 product of inertia, Ix, like they are in a 3 pair. Each pair have same value. So remember always that Symmetric axes of any object are always principal axis, but the principal axis may or may not be the symmetric axis. If the system is not symmetric, then there would be a principal axis but no symmetric axis. Mm. So what is, I mentioned principle of inertia. So what is principle of inertia? So when a like system is rotating about a principal axis, so then only the diagonal elements survive, and these diagonal elements are called principal inertia. Mathematically, if we take inertia tensor and find its eigenvalues, they are basically principal moment of inertia. Principal moment of inertia. Eigenvalues of inertia tensor. And what is principal axis? Are eigen vectors of inertia tensor. So before going to the examples, I want to also mention Euler's equation. So basically what Euler's equation does, Euler equation gives the motion of a rigid body with respect to one point under the action of torque tau. So the equation, that is I x is omega x dot minus I y y minus I z to omega y x is equal to tau x I y y omega y dot minus I x x omega z omega x is equal to tau omega. This is I z z omega z dot. So these are Euler's equation. They gave the motion of a rigid body. Like we know the motion of rigid body is basically ma is equal to force. Force is equal to ma. So here the equivalent of force is tau, which is torque, and z, the dimension of ma, inertia, moment of inertia is here equivalent of mass, and this is angular velocity dot omega x dot means this is acceleration. So this is basically the equation of motion of a rigid body. So let's dive into first example. First example is 4 point masses m, 2m, 3m and 4m are placed at the corners of a square of side A, shown in figure. Tensor for the axis shown in figure, and find the principal axis passing through point O. So the figure is this. This is O, this is X, and this is Y. These two sides symmetric. So basically this is N, this is 2N, this is 3M, this is 4M. This sides are A, so we add coordinate here. So this is A by 2, A by 2, comma 0. This is A by 2 minus A by 2, comma 0. This is minus A by 2 minus A by 2, comma 0. And this is minus A by 2, A by 2, comma 0. Okay? But you know that we are calculating, when we will calculate like moment of inertia, the minus sign doesn't affect so much because the square of a minus sign is also always positive sign. But when we calculate product of inertia, it is very so first calculate I axis, and this is a discrete mass distribution. So we know that I is for all of them. So this is basically a minus square. So this is basically m into a by 2 whole square plus 2 m a by 2 whole square plus 3 m a by 2 whole square plus 4 m a by 2 whole square. So for m it is a by 2, it is minus a by 2. No. And the multiple for 3 and 4 m this is negative. So ultimately that is 4. It's 5 by m square. Now I by when that is in my x also when z I square. We know z I is equal to 0. As z is equal to 0, this is basically m by x I square. So this is basically m a square by 4, 2m minus a by 2 whole square, 3m minus a by 2 whole square, 4m a by 2 whole square. This is also 5 by 2 m square. I with z is basically mi x square plus yi square. So we can write it mi xi square plus I mi yi square. So basically I xs plus I y here when zi is equal to 0. So it would be 2 into 5 by 2 ms square, that is 5 ms square. Now calculate product of inertia. Only ixy will survive because as zi is equal to 0, I z x is equal to I x z is equal to I y z is equal to I z y will be 0. So only I x y and y f will survive, that is mi. So that will be 2n minus a by 2 2 a by 2 3m minus a by 2 into minus a by 2 4m a by 2 into minus a by 2. Wait a minute. There is so as I was discussing this, only I x y and I y x will survive because as z is equal to 0, I z x is equal to I y z is equal to I z y is equal to 0. X I y I. So this will be m into a by 2 into a by 2 plus 2m a by 2 minus a by 2 into plus a by 2 plus 3m minus a by 2 into minus a by 2 a by 2. So that would give us m square by 2. So now we'll write the inertia tensor. We can write it m square 5 by 2 half 0 half 5 by 2 0 0 0 5. Okay, so now see, they have shown they have asked to write the inertia tensor, which we have written, and now find the principal axis passing through the point O. So for that we need to solve this matrix in eigenvalue eigenvector thing. So first we calculate the eigenvalue. Let lambda be the eigenvalue of the tensor. So lambda will be 5m square by 2 minus lambda m square by 2 m square by 2 5m square by 2 minus lambda 0 0 0 5m square minus lambda is equal to 0. So if we and that we'll get 5m square by 2 minus lambda into 5m square minus lambda. M square by 2, this m square by 2 into 5m square minus lambda minus 0 is equal to 0. So this becomes 5m square by 2 minus lambda whole square, 5m square minus lambda minus 5m square by 2 whole square into 5m square minus lambda is equal to 0. So we can take common 5m square by lambda, and this will become 5m square by 2 minus lambda whole square minus 5m square by 2 whole square. So you know either this became 0 or this is 0 or both. So 5m square minus lambda is equal to 0. Lambda becomes 5m square, and from this equation 5m square by 2 minus lambda whole square is equal to m square by 2 whole square. So 5m square by 2 minus lambda whole square is equal to plus minus 5m square by 2. Sorry. When lambda is equal to 5m square by 2 minus 5m square by 2, or 5m square by 2 plus m square by 2. This is 2m square. This is 3m square. Principle moment of inertia are 5m square, 3m square, 2m square. Now we want principal axis. So for lambda is equal to 2m square, eigenvector is alpha, beta, gamma. So that became 5m square by 2, m square by 2, 0, 5m square by 2, 5m square by 2, 0, 0, 0, 5m square into alpha, beta, gamma. When if you have taken the course mathematical methods in physics, you can solve now from this point. This is basically when you have written the inertia tensor, then it is only eigenvalue eigenvector problem. You have to just carefully and solve these things. So became, or you can write directly minus lambda here, it should be 0. That's the thing, but I am here doing step by step thing, that's why I am writing all these numbers. Now we need to equate this thing with this with this, and this. after equating we get by 2 alpha plus ms square by 2 beta is equal to 2 ms square alpha. So that became 5 alpha plus beta is equal to 4 alpha. So that is alpha is equal to minus beta. If we take this equation, square by 2 beta is equal to 2 ms square alpha. Equation we don't have to consider because here it says 5 ms square gamma is equal to 2 ms square gamma. So this is basically gamma is equal to 0. It can only happen if gamma is equal to 0. Here it is alpha plus 5 beta is equal to 4 alpha. 5 beta is equal to we can consider these things because either alpha beta share this relation or this relation. So if alpha is equal to 1, beta should be minus 1. Then eigenvector corresponding is equal to 2m square is 1 by root 2 1 minus 1 0. We got 1 minus 1 0. Then we need to normalize. So we get this thing. Similarly, eigenvector corresponds to lambda is equal to 3 ms square is equal to 1 by root 2. And for the lambda is equal to 5 ms square, it would be 5 ms square by 2 alpha plus ms square by 2 beta 5 ms square by 2 ms square by 2 alpha plus 5 ms square by 2 beta 5 ms square gamma. This will be 5 m 5 ms square beta. Here it will be beta. So beta. So actually alpha is equal to minus beta. We got the same results. Sorry for this mistake. 5 ms square gamma. So again gamma should be 0, and let us take first equation 5 ms square by 2 alpha plus ms square by 2 beta is equal to 5 ms square alpha. That is basically 5 alpha plus beta is equal to 10 alpha. So beta is equal to 5 alpha. Another equation is m is square by 2 alpha plus 5 ms square by 2 beta is equal to 5 ms square beta. So this is alpha. It's 5 beta to 10 beta. Beta. So if we take alpha is equal to 1, beta is equal to 5. If we take beta is equal to 1, alpha is equal to 5. So you can see there is a bit contradiction for principal moment 5 ms square. So when you go through the matrix method, and you should have some problems like this. Uh, so there, this eigenvector, I can say this is not a real eigenvector. The eigenvector is not in real place, or um, for this eigenvector we need to calculate further, and they are not basically orthogonal eigenvector. It will not give eigen for each specific eigenvalue. We should have eigenvectors, and then those eigenvectors should have orthogonal to each other. So for this, we would not get an orthogonal eigenvector to previous twos. So here we only consider this and this. So these are the eigenvectors, and they are basic and principal axis. Here two eigenvectors should have physical meaning in inertia, in the case of inertia tensor. So this thing is like by root 2 1 minus 1 0, and another is 1 by root 2 1 1 0. These are orthonormalized vector of each other. So these are should not be considered. Now move on to example 2. Says a uniform equilateral angle M and side A lies in XY plane as shown in So this is the figure. So it has mass m and side A. So we can see that y-axis is symmetric axis here. It must be a principal axis, and x is perpendicular to y. X-axis are principal axis, will not any product of inertia. So we calculate I-axis, which will be y, not y, y square plus z square into dm. Z is equal to 0, so it will be y square dm. dm is equal to rho into dv. Here the thing is in 2D. So d, instead of dv, it will be dA. So rho will be m by area. The whole area of this thing will be the area of the equilateral triangle root 3 by 4 a square into dA, it is dx dy. So Ixx will be here, we would write dx dy, so m by root over 3 by 4 a square y square dx dy. That's why double integration. So we dx then y square dy. So let us give the limit of x and y. The limit of x is from minus a by 2 to plus a by 2, minus a by 2 to plus a by 2. Okay, and here the limit of y would be from 0 to this. Okay, so what is this? We can write this equation, which will be y is equal to mx plus c. M is tan, here minus tan 60 degree, x plus c. C is this height, root 3 by 2a. So it will be minus root 3 x plus root 3 a by 2. So this is 0 minus root 3 by x, not root 3 by x, root 3x 3 by 2a. Then write this first equation like this. So y square will be y cube by 3 and the limit from 0 to this. So basically it would be p by 2a minus 2x whole cube by 3. So after all the simplification, it would be m by a square 0 a by 2 dx a minus 2x whole cube. That will be m square. So this will be like a minus 2x whole cube dx. That will be a minus 2x to the power by 4 into minus 2. So that would be half of a minus 2x to the power 4. That is sorry, this thing will be written here. After all the simplification is square by 8. Here when you put a by 2 here, you will get that. Now we calculate Iyy, and this is because z is equal to 0. dm remains the same. So now this is x square m root 3 by 4 s square dx dy. So m by 4m, this is x square dx, sorry, dy only. So here also this is a by 2, this is 0, 3 by 2 a minus 2x. So after all the calculation here, we will do for m square 0 a by 2 x square a minus 2x dx. Then it will be a into a by 2. After it is basically minus 2x cubed dx. So x cubed by into a minus 2 into x to the power by 4. So that's why this is that the integration with 2, like here in the integration I put the 2 and in the denominator. Here it is in this a and 2 is the numerator. All like according to integration rule, you all know that, and try to do that thing. If any problem, please like tell me. Otherwise it's basic integration only. So after all this calculation, it will give m square by 24. So izz will be basically ixx plus iyy, which will be m square by 8 plus m square 24, that is m square by 6. So therefore sheet answer is 1 by 8 0 0 0 24 0 0 0 1 by 6 into m square. So here I want to mention that here we dm is equal to rho dv. Basically we read that, plus we can also read sigma dA. Sigma is like mass divided by area. So that's why we have written like this. for 2D materials, we write dm is equal to sigma dA. Should go with a 3D material. So a hollow, right, circular cone has mass m, radius r, height h. Find the inertia tensor of the cone about the axis shown in figure. So when we consider, it is basically like this. X, Y, Z. We consider cone or cylinder, we should do the calculation coordinate. X is equal to r cos phi, y is equal to r sin phi, and r is from 0 to capital R, phi is from 0 to 2 pi, and z is equal to z. So the area element here is r d phi dr. Okay, so r d phi, okay, sorry, r d phi dl. dl basically infinitesimal length in the slanting surface. Okay, so this is basically our d phi, this is thing, and this is dl. So let us see, this is hr, this is dl, right, and this is dr. So it is basically dl is basically root over r square plus h square. This is by r. If we like do the use the trigonometric, this is dl. So dl by dr would be root over r square plus h square by r. So dl is root over r square plus h square by r into dr. r square plus 8 square by r d phi dr, and total area of cone. If we like put the value here d phi to dr, d phi is from 0 to pi and r to 0 to r. So if we calculate the thing, we would get, so this is 2 r. So the total area is nothing but to put the like integration value of these things. So 0 to 2 pi or 0 to r root over r square plus 8 square by r. There basically do phi and r dr. So that will become pi r root over r square plus 8 square. So dm, I have already sigma dA here. So this is m by pi r. We are doing this because this is a hollow right angular like cone. If it would be a 3D, then it will be rho dv. Then instead of area element, you should have taken a volume element. The is 3D, but it is basically a shell type thing. So root over r square plus 8 square into r d phi root over r square plus 8 square into r dr. So it will become m pi r square r d phi dr. So ixx, which will be y square plus z square dm, we will convert into r square sine square phi plus z square dm. Dm is basically m pi r square r dr d phi. Now we need to know what is the the r value. We know r r goes from 0 to 4, 0 to r, and d phi 0 to 2 pi. Sorry, here it will be dr. Okay, but what is z? For z, again, consider the triangle. This is h, this is r. Like if this is z, this is small r. Here we will consider this triangle A, B, C, D, E. A, D, E, and B, C gives, from the trigonometry, similar triangles. Z by R, H by R. So Z is equal to basically 8 into 1 minus small r by capital R. So the equation became Ixx r square sine square phi plus 8 square 1 minus r by r whole square m pi r square r d phi. Now we need to, here there is 2 plus sign there, so this will be 0 to r cube dr 0 to 2 pi sine square phi d phi plus here h square, this is 0 to r into 1 minus r by plus r whole square, dr 0 to 2 pi sine square phi, oh there is no sine phi, d phi, it will be only 2 pi. So after doing all this calculation one by one, we get m by 4 r square plus 2h square by 3. Calculate Iyy, that will be x square plus z square dm, basically that is r square cos square phi plus z square dm. We know what we have to put, z only thing it is difficult, and from ixs is there it was sine phi, this is cos phi, so basically cos square phi instead of sine square phi. Here it is cos square phi, result are same, and also we know they are equivalent, x-axis and x-axis and x and y-axis are equivalent. So Iyy is also the same, by 4 r square plus 2h square by 3. Okay, and Izz is x square plus y square dm. X square y square is r square sine square theta plus r square cos square, not theta, phi, r square sine square phi plus r square cos square phi. This is x, this is y, sorry, this is m by phi r square r d phi. This is basically r square, so only r cube, m by pi r square, this is r cube dr and d phi. That will give you mr square by 2. Of inertia tensor is h is equal to m by 4 r square plus 2h square by 3, 0 0 0 m by 4 r square plus 2h square by 3, 0 0 0 m r square by 2. So basically we take here area element, although this is a 3D object, but here IZZ, there in integration we couldn't put z is equal to 0. So integration became more complicated, but as it is a hollow 3D element, we took area element. When it is a solid 3D element, we took volume element. Next question, that is question number 4. Inertia tensor for system two by 3 minus 1 by 4, 1 by 4 minus 1 by 4, 2 by 3 minus 1 by 4, minus 1 by 4, minus 1 by 4, 2 by 3. So calculate moment of inertia oriented in the direction root 3. We know the value tan theta, tan 30 degrees on by root 3. So basically the axis is making 30-degree angle in x axis, y axis and z axis. So inertia tensor is given. We need to calculate the moment of inertia about the orientation. So basically what I do, we have the inertia tensor 2 by 3 minus 1 by 4, 1 by 4 minus 1 by 4, 2 by 3 minus 1 by 4 minus 1 by 4 minus 1 by 4, 2 by 3. And the orientation can see 1 by root 3, 1, 1, 1. New moment of inertia would be n. So this is a matrix multiplication. So 1 by root 3 into 1 by root 3 would be 1 by 3, 1, 1, 1. Moment of inertia, then 1, 1, 1. So this is 2 by 3 minus 1 by 4, 1 by 4 minus 1 by 4, 2 by 3 minus 1 by 4 minus 1 by 4 minus 1 by 4, 2 by 3. So when you calculate all those things, it will be 1 by 3, 1, 1, 1, and it will be 1 by 6, 1 by 6, and 1 by 6. So it will be basically, we can, it's 1, 1, 1, and 1, 1, 1. So this is 1. So this is 1 by 18. This is the moment of, no, 1 by 18 into 3. So this will be become 1 plus 1 plus 1. So this is 3. So this is 1 by 6. This is the answer. One by 18, 1 plus 1 plus 1. So 3 by 18, so 1 by 6. This is the answer. Next example. So next example is 4 equal point masses M are placed corners of a rectangle, sides A and B. Stem dated about a diagonal with uniform velocity omega. Calculate rotational kinetic energy angular momentum rotation angular momentum of system. So here we need to find the inertia tensor. It is similar to the previous example. We need to find the inertia tensor, then the moment of inertia about an axis and its kinetic energy and like angular momentum. So basically this is A, this is B. So this is M. The diagonal about which we need to calculate moment of inertia. Here the direction orientation of diagonal is not given. We need to calculate that. If we make this is theta, the orientation of it will be n. This is cos theta I plus sine theta j. Basically that becomes the orientation of any like line, because you need to understand this is actually a unit vector kind of thing. So cos theta is basically a by root over a square plus b square I, and sin theta is b by root over a square plus b square j. We can write it as a root over 1 by a square plus b square as a, b and 0. Good. Now please wait a minute. Wait some minutes because again it's going. I will upload the combined file. So this is M, this is M, this is A 0 0 0, that is A 0 0, that is A B 0, this is 0 B 0. And already we have calculated the orientation of diagonal, that is basically root over 1 square plus b square ab 0. This is the diagonal, like direction of the diagonal. So ixx basically miyi square plus zi square. Z is 0, so basically miyi square. Only two of the particle have y particle, that is y coordinate, that is like this thing and these things. So that would be 2mb square. Iyy similarly only xi square will survive, and two of the particle has a coordinate, that is this and this. So that is 2ms square. Izz is basically ixx plus iyy, that became 2m square plus b square. And we have already seen when z is equal to 0, izx is equal to ixz is equal to iyz is equal to y became 0. So only ixy will survive. X and y both will be positive, then it will survive, and only this non-zero, x and y only both are non-zero, then it will survive. Only this particle contribute to the product of inertia. So this is mixiyyi, so that will be minus mab. So inertia tensor is 2mb square, 2m square square plus b square m. This is ab, this is mab, this is 0 0 0 0. So now we need to calculate moment of inertia. The system is rotated about angular momentum. This is our angular moment of inertia about the axis of rotation, that is n. It will become this ab comma 0. Can take m out of the inertia tensor, so 2b square minus ab 0 to minus ab 2a square 0 0 0 2a square plus b square into ab 0. And that will be m square plus b square. So that became ab 0, and this thing is ab square b comma 0. Total moment of inertia about the axis of rotation, which is the diagonal, is become a square b square plus b square. So we know the kinetic energy. Kinetic energy K is equal to half of I omega square. So here half I we know due to moment of inertia when the system is rotating about its diagonal is basically 2m square b square by root over a square plus b square. Omega square, this 2 will cancel out, so m a square b square by a square plus b square into omega square. Lastly, get the kinetic energy. Now the angular momentum. Rotation. To the square. We want to calculate the total angular momentum of the system. Girls. Axis is written about diagonal. So we have theta. I so that's what we make up. So basically, we put all those things in that thing. So honestly, maybe in maybe in expensive as well. That's right. That's right. Make up and as well. That's really yeah. And it's true. And it's and then zero is So this is like the angular momentum about the point, and the previous series and how that. So I will be looking in the PowerPoint. Copy this link and now we go some focus increments. Rules on a horizontal surface such that center of the sphere moves with speed v. Calculate finite energy and angular momentum of the sphere. So the velocity transition, this is the transition velocity, which is omega angular velocity in so that's what we are. And the energy will be half of mv squared plus half of I omega squared. So half of mv squared plus half of t in r squared because of all the sphere we are having. So the combination of all of space to in r squared into v squared plus squared. So that is 6 mv squared. Angular momentum into I omega plus VER. So equal to 2 by 3 mr square plus v by r plus mvr. So that is 5 by 3 mvr. Now, next question. We of mass m and radius r rolls and from rest if the center of a ring is initially at a height h, the angular velocity when the reaches the base we do total energy is equivalent to not physically here. It's basically h. Here it is on the r. Basically, it looks h minus r. Here, yeah. The total energy here should be equal to total energy here. So, this position A, this position B, kinetic energy is potential energy position, kinetic energy position. Because potential energy here. So, the kinetic energy was 0. So, whatever loss in the potential energy will happen in the gain the kinetic energy. Potential energy is gain in kinetic energy. The basic thing. So, potential energy loss will be mg h minus r. Kinetic energy is here. There will kinetic energy gain is whatever it big is not really half of I don't know the square. It's half of mv square. Here we need to put the moment of inertia, which is m r square for the into over square. Now we can do the so we change this m omega square r square plus half of m r square over square. So this we get m r square over square. So omega will be over g h minus r by r square. So that's how we'll like consider friction. So this is theta, this is ng. So this is ng cos theta, this is ng sin theta. Okay, this is ng sin theta. This is and the acceleration and the acceleration also in this direction. Friction is moving in this direction, it will be in this direction. So A is equal to alpha, we know that. Here, see, this is the equation 1. N G sin theta minus theta is equal to mass acceleration. This is equation 2. We have our bias of equation and either if R is a this is the equation. If we add equation 2 plus equation 3, it gives us mg sin theta A plus R square. This will give sin theta and allow and mass. Okay. So now if we go this one, if we be done by R square, g sin theta plus R and mass. So the rolling force is static in nature. So R should be and possible. Basically, by R square g sin theta I R square should be less than equal to ng cos theta. So you should be equal to tan theta 1 plus sorry. So now let's see our derivation. The last question. Question 8. A solid sphere goes down or inclined plane. Height is as shown in figure. Calculate time taken by sphere to each other. Also calculate number of coefficient of friction necessary for you. So the moment of inertia is 2.5 m square. We know that acceleration if by g sine theta. If you don't remember this equation, you can draw the and then put the value. So if you put the value, say 1 plus by 5 m r square m r square to be m g sine theta by and this is the inclined plane. Okay. So this is x. So sine theta be h by x is be h by that is the distance covered. So time should be the acceleration. So x is equal to half of a square. T is equal to 2 over 2 is by a. So that is 2a by sine theta into 5 g sine theta into s. So it is equal to 4h 5 g sine square theta. And the coefficient mu is basically 10 by 1 plus in r square by I. So can see using so that is tan theta 1 plus in r square by 2 by 5 in r square. So that is 7 tan theta. This is the like using the equation, like see when the ball is thrown down or sphere, here the solid sphere is rolling down and there is like friction involved, then this can be minimum coefficient of friction. For today, Okay. There will be an extra class, and if you want any specific kind of question to discuss there, uh, please let me know in the forum or in the comment of this video. Thank you.